Hello and welcome. So today we're going to graph a transformation. So first off, let's look at our different kinds of graphs. All right, the first one happens when we have an x squared graph. The next one happens with a square root. And last but not least, absolute value. So the x squared is a quadratic. It is this parabolic kind of U-shape graph. Square roots, I call them half seagulls, right, where you have essentially kind of half a graph. And then the other one, you have the v, which is your absolute value. All right. So for all of these graphs, keep in mind in order to graph them, you need to plot that first point, the vertex for your quadratics, the vertex for the absolute values, and then your minimum, your starting point for the square roots. Okay, if you don't graph that point first, the tool will not graph it correctly. So do keep that in mind. Alrighty. So what we're working with here, we see this square, and that tells us that we're going to be using this U shape, the quadratic, as our graph. Okay, and for quadratics, your table for that, what it looks like, your points, is that it'll start at 0, 0. How we know it's 0, 0, you plug in x, you get out y. So we plug in 0, 0 squared, 0. You plug in 1, okay, 1 squared, 1. Plug in 2, 2 squared, 4. Okay, x goes in, y comes out. Alrighty, so now we have our base points. So now we got to figure out what transformations we're looking at. First thing I see is I say, okay, we have this minus 6 and plus 3. Remember, all addition or subtraction are known as shifts. Okay, now depending on where you see that addition or subtraction determines whether or not they are horizontal or vertical shifts. First off, I'd say, okay, this minus 6 is on the inside of the square, inside of the operation that determines what your graph looks like. Well, that makes this a horizontal shift. Because if it's with the x, remember x moves left to right, that is your x-axis, so that's why it is a horizontal shift. Now, on the outside of your function, we have this plus 3. If inside of the operation is horizontal, then that means the outside must be a vertical shift. And that is true for all of the parent functions. This same pattern shows up in all parent functions. All right? So now we got to figure out, okay, we know it's horizontal, we know it's vertical, now to figure out which direction it's going. Vertical is the easier shift where you say, okay, it's plus 3. Which direction is plus 3 for y's? Well, plus 3 is going up. So you have a vertical shift up 3. Horizontal is a little more difficult. You see the opposite of what you see. So if this is minus 6, while minus 6 is, yes, indeed going left, a horizontal shift, minus 6 actually turns into right 6. The idea is you start with x squared. And if you have x minus 6, in order to get back to just x squared, you would have to add 6 to cancel out that shift. So in other words, you're moving right 6 in the equation. Okay? Alrighty. So I'd say, alright, your original point, 0, 0, right? Your original point is here. And then all you do to graph the transformation, you say, okay, we're going to the right 6. So right 6 and up 3. This is your new 0, 0 point that used to be there. Okay, from there, you'd say, okay, it's only a shift, so the pattern remains. This next one would have gone over 1, up 1, still remains. The other one is over 2, up 4, still remains. Okay, or you could have graphed the points normally, and then from there you could have said, okay, over 6 would have left us here, up 3 would have brought us to the point. Left 6 was there, up 3 would have brought us to the next point. It's fine no matter which way you go if you want to graph the original and then do the shifts on it, or if you follow the pattern, then you're good to do it. Okay, either or. And now we know quadratics have, I kind of missed there a little bit. There we go. Symmetry, which means that you would have your other points just in the other direction. And that would be it. That would be graphing your quadratic. So in order to use the tool correctly, just choose your first point at the vertex, and then any of these other points would graph the quadratic for you. And that is similar to the other parent graphs as well. All right, thanks for watching.